Okay, so Leetcode practice time. In this video, there are two goals. The first goal is to see how to solve this problem. Then we are going to put some code here. And the second goal is to see how we should behave during a real interview. So let's get started. Remember, in a real interview, the first step is always to try to fully understand the problem. If there is anything unclear, please bring up the question. And also, at the same time, think about some edge cases that can potentially break your general algorithm in the next step. So let's read this problem. So find the largest value in each tree row. So given the root of a binary tree, return an array of largest value in each row of the tree, 0 to index. Alright, so, okay, it's 0 index. Example for this one, it's going to return 1, 3, 9 because for each layer, the corresponding numbers are 1, 3, and 9. Alright, I think it makes sense. Let's see some constraints. It says that the number of the nodes within the tree would be within 0 to 10k, and the value for each node is within the range of int 32. So I think it's pretty clear. One edge case I can think about is if the root to be none, which means that it is an empty tree. But let's see if it's going to be covered by our general algorithm. So for the next part is about finding a solution. So how to solve this problem? So I would say this is a pretty typical BFS problem. We just use BFS to solve this problem, and the runtime is going to be O of n, and it's the number of the nodes within the tree. And after we find the solution, the next part is about doing some coding work. So for coding, first of all, don't be too slow because there is limitation on the time for a real interview, and also take care about the correctness and the readability within the code. Then let's get started and do some coding work. So first of all, if root is equal to a non-pointer, then we are just going to return something empty. So we say, let's say max each layer is equal to new linked list. If it's none, then we just return the max each layer. Max, okay. So for the BFS, we need to get a queue. So we will have queue as a tree node, new underlying implementation is a linked list. So I would be the not queue.empty. Yeah, queue is not empty. Then first of all, we are going to see the size of the queue. So in size is equal to queue.size. And we are going to iterate through each layer, and before each layer we need to have a max. So the max so the max would be, let's say, integer dot main value in I is equal to 0, I smaller than size, plus I. So this for loop is about iterating through all the nodes within a layer. So we're going to do the pop equal to q dot pop. This is full, okay. So max is equal to mass dot max and no dot value. Okay. And then finally, after we iterate through the layer, we are going to push the maximum value into the max each layer. It's going to be add the max. And finally, we return max each layer. So the next part is about testing. After you're done with coding, you need to do some testing. So better to use some simple example to explain how this piece of code is going to work, and at the same time do some sanity check about the logic. So let's use this as tree. So it's not a tree, so it's not an empty tree, so we are not going to touch this if branch. And we have the new queue, and the queue we should add the root node into it. So first of all, we add the root node into the queue, and while it is not empty, first of all we are going to get the size of the current layer. And for the first layer we only have the root node, so it is 1, so we are going to add 1 into it. And also, yeah, so we need to add the left and right children into our queue. So pull max.max if node.left is not equal to none, then queue add the node.left. So if node.right is not equal to none, then you're going to add node.right. Yeah, so and for the root node, for this one you're going to add both the left and right children into the queue, and this layer, after this layer finishes, we add the 1 into it. And next time we have this queue.size as equal to 2 because we have 2 nodes, 3 and 2 in it. And we initialize the max as the main value of the integer, and we go through the 2 nodes. So first of all, we pull node 3 from it, and we set the max as 3, and we are going to put its left node and right children into the queue. And then the next one is 2, which is smaller than 3, so we are not going to update max. So similarly, we are going to have the last layer to be visited. So I think that's pretty much it. I think we should be in good shape about this code. Let's do some testing. Okay, so it works well. Let's give it a summation. Okay, so everything works well now. I would say for the test case setup, to have good enough test coverage, I would suggest setting up 2 different test cases. One is root as empty, the tree as empty, and the other one is just a regular tree. So that's it for this coding question. If you have any question about this puzzle or about the solution, feel free to leave some comments below. If you like this video, please help subscribe to this channel, and I'll see you next time. Thanks for watching.